What if every pattern in nature, from the spiral of galaxies to the firing of neurons, could be cracked some way? Imagine if every hidden rhythm in nature, from the way your heart beats to the way galaxies swirl, could be uncovered. Welcome back to SkyTech and Science, your go-to podcast for understanding the groundbreaking frontiers of technology and science. I'm your host, Hector Duran, and today we're diving into a mind-bending idea that's shaping the future of AI and our understanding of the universe itself. We're talking about Demis Hassabis' conjecture on learnable patterns in nature, a concept that redefines what we thought classical computers could achieve. Now, Demis Hassabis, the brilliant mind behind Google DeepMind and a recent Nobel Prize winner, dropped what he called a super interesting conjecture in his Nobel Prize lecture. He posited that any pattern that can be generated or found in nature can be efficiently discovered and modeled by a classical learning algorithm. Think about that for a second. This isn't just a bold claim, it's a profound statement about the inherent structure of our reality and AI's capacity to unravel it. What kind of patterns are we talking about here? Pretty much everything. From biology and chemistry to physics, cosmology, and even neuroscience. Demis explains that this idea stems directly from the incredible successes of projects like AlphaGo and AlphaFold. These AI systems tackle problems so complex, like finding the best move in Go or the exact shape of a protein, that brute forcing every possibility would take more time than the age of the universe. Yet, they solved them. How? By building models of these environments that intelligently guide the search. The core insight here is that natural systems aren't random. They possess intrinsic structure because they've been shaped by evolutionary processes. Demis sometimes calls this survival of the stablest. This applies not just to living organisms, but also to geological formations like mountains shaped by weathering over millennia, or even the stable orbits of planets and the shapes of asteroids formed by cosmic processes. If a pattern in nature has endured, it likely has an underlying structure that can be learned. This is a stark contrast to abstract problems like factorizing huge, random numbers, where there might be no pattern to learn, potentially requiring a quantum computer. But for the vast majority of nature's problems, there's a lower dimensional manifold, or a gradient, that can be followed, and neural networks are incredibly adept at doing just that. One of the most compelling examples of this conjecture in action is with fluid dynamics. Traditionally, things like the Navier-Stokes equations and weather prediction have been seen as incredibly difficult, intractable problems for classical systems, requiring massive supercomputers. Yet, Google's Veo video generation model can model liquids and materials, even complex specular lighting, with surprising realism. How does it do this? By simply watching YouTube videos, Veo is reverse engineering and extracting some underlying structure around how these materials behave. It's not perfectly understanding physics in an anthropomorphic sense, but it has modeled enough of the dynamics to predict future frames coherently. Demis calls this an intuitive physics understanding, much like a human child develops, allowing it to predict how things are supposed to work intuitively. This capability even challenges long-held theories in neuroscience that intuitive physics requires embodied interaction. It seems it can be learned through passive observation. This leads to a fascinating connection with the P versus NP problem in theoretical computer science, which asks, is every problem whose solution can be quickly verified also quickly solvable? Demis sees the universe itself as an informational system, making the P equals NP question a physics question. He suggests that a huge class of problems can be efficiently solved by classical systems in polynomial time, essentially confirming that neural networks running on normal, classical computers can go much further than we ever thought possible. It's an exciting time to be alive, witnessing AI not just replicate human feats, but potentially uncover the very informational fabric of our universe. The implications of this conjecture are enormous, hinting that many of nature's deepest secrets might be within reach of classical learning algorithms. That's all for today on SkyTech and Science. Join us next time as we continue to explore the most fascinating breakthroughs in our world. If you liked what you heard, share it with a friend, follow the podcast, and let us know what topic you'd like us to explore next. I'm Hector Duran, and I'll catch you next time as we explore the cutting edge of science and technology.